Welcome to AI Frontiers. Today's episode, titled Computation and Language, Breakthroughs from a Single Day, explores trends, insights, and a deep dive into the field of computation and language, or cs.CL, as of September 19, 2025. On this landmark day, 52 research papers were published, each contributing to the evolving landscape of AI-human communication. This episode will highlight key themes, examine standout work, and discuss the future directions that are shaping the way machines understand us. Imagine a world in which every machine interaction feels as intuitive and empathetic as speaking with a lifelong friend. On a single day, 52 teams released groundbreaking research, each representing a leap forward in machine-human conversation. Consider the experience when your phone truly understands your intent, or the unseen innovations behind every seamless translation. These advances signal a transformation in how technology communicates with us. Today, listeners are invited to explore this hidden world and discover the forces driving it. Computation and language is at the heart of AI communication, where machines are increasingly learning to speak human. With 52 new papers published in a single day, the field has unveiled the latest advances in how technology processes and responds to everyday interactions. These findings have direct impacts on the technology used daily, from voice assistants to automated translators. In this episode, the focus will be on unpacking these innovations, the challenges they pose, and their real-world implications. Stories, emerging research themes, and a deep dive into a pivotal study will provide a comprehensive understanding of this dynamic domain. Visualize computation and language as a vibrant city. The most advanced language models, such as GPT, Llama, and Claude, stand as towering skyscrapers. Surrounding neighborhoods specialize in translation, speech, and dialogue systems. Bridges represent multimodal technologies that connect text, speech, and images, facilitating seamless data exchange. Beneath the surface, hidden infrastructure, rooted in linguistics and cognitive science, powers the entire system. The city is inhabited by researchers, engineers, and billions of users worldwide. This interconnected, expanding metropolis underscores the field's global influence, constantly evolving with new innovations and breakthroughs. The alignment of language models with human values has become a central theme. As these models grow smarter, their fairness and trustworthiness are under scrutiny. Alignment research focuses on teaching artificial intelligence systems to reason and negotiate in ways that mirror human behavior, ensuring that AI decisions align with societal expectations. A notable example involves developing a robot diplomat capable of understanding and practicing compromise. Researchers are actively evaluating fairness in complex scenarios such as negotiations and crisis response to ensure that language models not only perform well, but also uphold human values in decision-making processes. The field is experiencing rapid progress in multimodal and multilingual modeling. Multimodal models are capable of processing text, speech, and images simultaneously, while multilingual models switch languages with the agility of seasoned travelers. Unified translation frameworks are emerging, enabling seamless translation of both speech and text within a single system. These technological bridges not only span languages, but also integrate multiple forms of communication, facilitating more inclusive and accessible tools for global users. Such advancements are breaking long-standing language barriers and broadening the scope of human-computer interaction. Bias mitigation and efficient learning are critical concerns in contemporary language modeling. Bias, if unaddressed, can influence real-world decisions in contexts such as hiring or education. Techniques like frequency-framed prompting are being used to make AI-generated summaries more impartial. Concept unlearning offers a method to remove bias from a model's internal representations, essentially clearing the AI's mind. Resource efficiency is also prioritized, with new methods for data compression and model pruning, making artificial intelligence systems more sustainable and cost-effective. This is analogous to city planners, ensuring that all districts receive equitable resources, enhancing fairness across the technological landscape. Several standout breakthroughs from the front lines are reshaping how machines understand humans. Mina Arzadi and colleagues demonstrated that removing bias from internal model representations can boost fairness by 82%, with no reduction in accuracy. Yunze Wan's group developed Persona Evolve, a framework that narrows the gap between AI and human behavior realism by 84%. Jinghao Zhang's team introduced CultureScope, a system revealing hidden cultural blind spots in language models. Senkang Hu's work on steering vector decoding enables real-time adaptation of models without retraining. Each of these innovations contributes to a more nuanced, equitable, and adaptable AI landscape. A pivotal study, Intrinsic Meets Extrinsic Fairness, assessing the downstream impact of bias mitigation in large language models by Mina Arzadi and team, addresses a fundamental question: can AI fairness be improved before decisions are made? The researchers compared intrinsic bias mitigation, using concept unlearning to cleanse the model's internal state, with extrinsic approaches that balance or augment the training data. These strategies were tested on tasks such as salary prediction, employment status, and credit worthiness using both frozen feature extraction and fine-tuned classifiers. This comprehensive evaluation provides valuable insights into the most effective methods for achieving fair AI outcomes. Delving into the technical methods employed by Arzadi and colleagues, concept unlearning is highlighted as a technique that systematically removes bias from a model's internal representations. In contrast, data balancing involves generating or weighting training examples to reduce bias in the model's outputs. The primary metric for success is demographic parity, which measures the independence of outcomes from sensitive attributes such as gender. The study utilized real financial datasets with human-labeled ground truth to ensure robust evaluation. At the core lies representation learning, which governs how models interpret and process data, making these technical approaches critical for advancing fairness in AI. The impact of Arzadi et al.'s paper is significant. Concept unlearning achieved a 95% reduction in internal gender bias and improved fairness in outcomes by up to 82%, all without sacrificing accuracy. Importantly, early, model-centric bias mitigation outperformed methods that focused solely on data adjustment. The research was inspired by real-world incidents of unfair AI decisions, providing a strong human element to the technical work. By setting new standards for responsible AI deployment, particularly in sensitive domains such as hiring and lending, this study has established a benchmark for ethical and effective artificial intelligence. Looking to the future, the field of computation and language is likened to a swiftly moving river, continuously reshaping its boundaries. The next phase is expected to prioritize psychology-driven and human-centric frameworks, integrating insights from social sciences to inform model design. Scalable tools such as CultureScope and Persona Evolve will become more widespread, enabling broader adoption of fair and interpretable AI systems. Models will increasingly possess the flexibility to switch tasks and languages with ease, akin to a traveler hopping trains. Central philosophical questions remain, including whether language serves merely as a mirror or as the fabric of human thought itself. In summary, the field of computation and language is marked by creativity, urgency, and a strong sense of purpose. Recent breakthroughs are advancing fairness, realism, and cultural competence, while innovative frameworks are closing long-standing gaps in bias and trust. As AI systems become more attuned to individual users, understanding their language, culture, and values, the possibilities for meaningful interaction expand. Listeners are invited to imagine engaging with an AI that truly understands them and to participate in shaping the ongoing conversation. The journey is collective, and continued exploration, discussion, and innovation are encouraged. This presentation was synthesized through the collaboration of advanced AI and human expertise. The content structure and summarization were powered by GPT 4.1 from OpenAI, with text-to-speech provided by Deepgram, and image generation by OpenAI systems. Every segment underwent human expert review to ensure clarity and accuracy. While every effort was made to deliver trustworthy insights, some oversights may remain. References have been provided for further verification. This approach demonstrates the strength of combining rapid AI synthesis with careful human judgment to offer reliable and insightful analysis. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.